Okay, this is a little tutorial just to show you how to take sugars from that Fischer diagram. So this is a Fischer diagram, and turn it into a ring. So remember when you're doing this, that the interaction or the new bond that's going to form is between the carbon that's inside of the carbonyl right there, and then the oxygen in the alcohol that is farthest away from that carbonyl carbon. So you're actually going to draw a new bond. It looks like it's a really long distance, but the molecule actually kind of folds, and it ends up being a short bond. So if I wanted to draw that, what I'm going to say is this oxygen right here is going to be this oxygen right here. So now I'm going to draw the rest of the molecule in a different color, just so that we can kind of tell the difference. Okay, so how many carbons do I have? 1, 2, 3, 4, 5. I have 6 carbons. Okay, so in my 6 carbons, when I draw this, the next carbon go down, and this is carbon number 1. So this carbon is my carbon that was in the carbonyl bond, but it's no longer in the carbonyl bond. It can't have that double bond, because then it would have too many bonds associated with it. It would actually have 5 bonds, and it can't do that. And so what actually happens is that the hydrogen will actually move, and what you'll end up having is a hydroxyl, right? That's attached to that carbon. So that carbon is attached to 2 oxygens. One of them is in the original hydroxyl there, and the other oxygen is right here. And that's what picks up the extra hydrogen. Okay, so let me kind of undo those extra lines. All right, so that's carbon 1, carbon 2, carbon 3 is in this corner, then carbon 4, carbon 5, and carbon 5 goes into a bond with the oxygen. So where does that carbon 6 go? Because this carbon 5 right here, right, goes into the bond with the oxygen, and then that oxygen is bound to the carbonyl carbon. So 5 goes into the bond with the oxygen that was in the hydroxyl, and then that oxygen is bound to the carbonyl carbon. So the carbonyl carbon is what becomes the anomeric carbon. And so if I want to show, let me get rid of those arrows. If I want to then show what happened to the 6th carbon, well, this 6th carbon is going to be bound up above the ring in CH2OH, just like that. Okay. Okay, now I have to worry about all the other stuff. So remember the rule. If on a Fischer diagram, it's on the right side, it's on the bottom of the ring in a ring structure. If it's on the left, it goes on the top. So all of this stuff, and we don't worry about that 5th carbon, because we already kind of took care of that 5th carbon, right? We put the CH2OH, and that means it actually has the hydrogen coming down. So we can kind of erase that 5. We know we've taken care of carbon 5. So we got to look at carbon 2, 3, 4. Okay. So when we look at carbon 2, we have an OH, and that OH is on the left. So on carbon 2, I'm going to erase my carbon 2 number, and I'm going to put my hydroxyl going up and my hydrogen going down. Okay, so let's look at carbon 3. When we look at carbon 3, what we see is the hydroxyl going up, hydrogen going down. Carbon 4, look at carbon 4, I see hydroxyl going up, hydrogen going down. Now, that's only one way that we can draw this. And the way that we've drawn this is that we've put the hydroxyl right here, and this carbon that's outside of the ring on opposite sides of the ring. The CH2OH is on the top of the ring. The hydroxyl on the anomeric carbon is on the bottom of the ring. And so what we call this is, because they're in a trans configuration, right? They're on opposite ends of the ring. We call that alpha. So this is the alpha anomer. Now, if I want to draw the beta anomer, I just need to change my position of the 2. So what I'm going to do is I'm going to copy that exact thing that I drew. Okay, so it looks exactly the same. So now I cannot change my carbon that's there up at the top, but what I can change is this hydroxyl over here. So what I'm going to do is I'm going to take that hydroxyl, and I'm going to move it, and I'm going to move it to the top. So that now, and I guess I really should have put a hydrogen here. So now I have the hydroxyl going up. And so that's always what we compare it to. The hydroxyl is going up. The CH2OH is going up. So they're on the top. They're both on the top of the ring. So this is cis, and cis is the beta anomer. Okay. So let's try it again. Now, before I do this one, you should pause the video and you should try to do this one yourself. Now that you've kind of watched me do one, you should try to do one. Okay, so we have to do the same thing, draw the alpha and beta anomer. So my new bond is going to be between this carbon and this hydroxyl, right? So that's going to be my new bond that's going to occur right there. So I want to draw my oxygen, and it is kind of important to know how many carbons you have so you know how big your ring is going to be. So that's 1, 2, 3, 4, 5 carbons in the ring, plus this oxygen, so that'll be 6 things in a ring, and then your 6th carbon is going to go out of the ring. Okay, so if I do that, my oxygen, and remember that this oxygen right here, right, is this oxygen right here. Okay, so then I'm going to bond it to carbon number 1, so that's carbon 1. See if I can write. Okay, then carbon 2 is here, carbon 3, carbon 4, and carbon 5. Okay, where does carbon 6 go? Carbon 6 goes up, CH2OH. And what else is bound to this 5th carbon? This 5th carbon has that CH2OH. It has the oxygen. We drew that. And what's the last thing that's attached to it is this hydrogen. So if you want for number 5, you just draw that line going down and you give it a hydrogen. Okay. All right. But a lot of times in these structures, we don't write the hydrogens. We know they're there, but we don't write them. Okay. So now, I need to make sure about what goes on the other carbons. So I know that first carbon, right, has 2 oxygens now bound to it. So we have to put in an extra hydroxyl group, right? Because it has that extra hydrogen, has that extra oxygen attached to it. So I put a hydrogen on the other side. Now, carbon 2. On the left-hand side, I have an OH, so that goes up. I'm going to erase my 2. That goes up, OH. Hydrogen goes down. Carbon 3. What's on carbon 3 on the left? A hydrogen, so hydrogen goes up. Hydroxyl goes down. Then carbon 4. Look at carbon 4. Hydrogen goes up. Hydroxyl goes down. Okay. Now we got that done. So we want to do exactly the same thing. Oh, let's identify. Is this the beta anomer or the alpha anomer? Well, we have one on top and we have one on bottom. So this is trans. So this is the alpha anomer. So now what I want to do is I want to copy exactly the same thing. See if it fits. Oh, not quite. Let's try this again. Let's shrink this a little bit. Okay. And then we'll scooch it over. There we go. Okay, so now how do I convert this from the trans anomer, this is the trans anomer, into the cis anomer? Well, all I need to do is exchange my hydroxyl and my hydrogen that are going on right here. So all I'm going to do is exchange them, okay? So I put an OH at the top, a H at the bottom. And now if I look, my OH and my CH3 are both on the top of the ring. So this is a cis or beta anomer. Okay. All right, now the last one, you actually have to take this and then draw a glycosidic bond. So it says that lactulose is a disaccharide used in the treatment of chronic constipation. Its formal name is galactose beta-1,4 fructose. So that tells me that galactose is participating in the glycosidic bond with its anomeric carbon, and that is carbon number 1. Then fructose is bound to it at carbon 4. And I know that the anomeric carbon and that hydroxyl that's normally attached to that anomeric carbon is in the beta conformation, which means that it's on the top side of the ring, just like that extra carbon that's on the top of the ring, okay? So we need to draw the structure. So in order to draw the structure, you have to go and get those individual Fischer projections of the carbons. And so they were on page, what was that? Oh, page, it was 320 something. Here was not 232 and 233. One was in the figure on 232 and one was on the figure in 233. And that's where I pulled them from. So I just pulled them straight from the book. Okay, so the first thing is that I want to draw these in a ring structure form. But what you have to remember is anytime you see this CHO, what does that actually mean? So I wrote it up here. CHO is equal to really a carbonyl carbon that's attached to a hydrogen. You just kind of have to know that. That's how they abbreviate it. And you just kind of have to know that. Okay, so what I'm going to do is I'm going to come over here and I'm actually going to erase that. And I'm going to write what I want it to be, right? Well, not what I want it to be, but what I know it to be, right? So I have a carbon. Whoa, that's really too big. All right, so I have a carbon, and that carbon is a double bond to an oxygen and a hydrogen. And you could have done it the other way around. It doesn't matter to me. If you want to do the, oh, darn it. If you want to do it this way. Do the carbon double bound to an oxygen bound to a hydrogen. It doesn't matter. That part doesn't make a difference. Okay. All right. So now I want to go in and I want to number my carbons. I have 1, 2, 3, 4, 5 in the ring. Then that fifth one is going to make a bond right to this oxygen. And then this oxygen is going to come and make a bond with this carbonyl carbon. So I have 5 carbons and 1 oxygen in the ring. So that's going to be a 6-member ring. And then on the outside of the ring is going to be my 6th carbon. So if I want to draw that, see if I can zoom out and keep it in the same view. So if I want to draw that, I'm going to draw right here. This is going to be my anomeric carbon. So I have an oxygen, right? And then I'm going to come down and I'm going to make it into a bond to carbon number 1. Okay, so that's carbon number 1. Then here's carbon number 2. Here's carbon 3, carbon 4, carbon 5, and then carbon 6 is going to come up here, OH. That's going to be carbon 6, okay? Now, I need to go in and fill in the rest of it. I was told in the question that this is a beta anomer, right? It tells me right there it's beta. So I need to go in, and when I put in my hydroxyl group, I'm going to put it in the beta conformation. So remember, beta means cis, so they're both going to be above the ring. Right? Okay. Now, I'm not going to draw in the extra hydrogens. I'm just going to draw in the hydroxyls because it's a little less to actually have to look at, right? So carbon 2 has a hydrogen on top, hydroxyl on the bottom. So put hydroxyl on the bottom. And I'm going to erase my numbers as I do them just so that I know. 3, my hydroxyl is going to be on the top. So I'm going to put an OH here. Carbon number 4, my hydroxyl is on the top again, right? Okay, so now I've got my first galactose ring drawn. Now what's going to happen is eventually that we're going to participate in a glycosidic bond, right? And it's a beta 1,4, so it's a beta 1,4 glycosidic bond. So that tells me that carbon 1 on our first sugar, which is galactose, is going to participate. So if I look at that, then I know that it's this carbon right here that's participating in the glycosidic bond. So that's carbon 1. So we're good on that. Now, I want to draw fructose. Fructose is, let's count our carbons. 1, 2, 3, 4, 5, 6. Okay, so I have 6 carbons, but what's going to be in the ring? Carbon 2 is going to be in the ring because it is going to form a bond with this oxygen right here. And it'll bond with that oxygen right there. So carbon 3 will be in the ring, carbon 4, carbon 5, and then an oxygen. So I actually only have, right, 1, 2, 3, 4, 5 things going on inside of the ring. So I'm going to have a different shaped ring. I'm now only going to have a 5-membered ring. To make a 5-membered ring, it kind of looks like a house, right? So I have an oxygen and then I have 4 carbons. So this is actually going to be carbon 2, because that's going to be my anomeric carbon. That's the one that was in the carbonyl double bond. 3, 4, 5. Okay, now let's try to fill in what's bound to these things. Look at carbon 2. Carbon 2 has carbon 1 bound to it. So it doesn't matter, for this one they didn't tell you if this fructose is in the alpha or beta configuration. So it doesn't matter which way you put it. But you're going to have to put that CH2 and an OH, and on the other side an OH. So it doesn't matter which way you put it, but you have to put this oxygen that picked up a hydrogen and lost its double bond, and you have to pick up this CH2OH. And so it doesn't matter if you put one on top, one on bottom, doesn't make a difference. They didn't tell you. Okay, now for my carbon 2, we took care of. Carbon 3, my hydroxyl is going to go up. Carbon 4, my hydroxyl is going to go down. Carbon 5. Now, carbon 5, I have 3 things attached to it. I have this hydroxyl. Well, that's this oxygen. So I've taken care of that, right? Now I need to take care of the rest. I need my CH2OH and a hydrogen. So what's going to happen to, I'm 2, 3, 4, yeah, 5. Excuse me. When I look at carbon 5, there are 2 other things I have to put on. I have to put on a CH2OH and a hydrogen. Always put your CH2OH going up, because that's like the default drawing for our carbon rings. And then the other thing is a hydrogen, and I'm not going to draw it. Okay. So I was told that this is a beta 1,4. So where's the 4? So if I go 1, 2, 3, 4, this is the carbon that's going to participate in the bond. Let me put that in orange, just like I did on the other one. Right there. That's the carbon that's going to participate in the bond. So I know which 2 are going to participate in the bond. So actually what I can do is I can take this and I can scooch it closer. Now, what's going to happen to form the glycosidic bond is that I'm going to have to release water. So in order to release water, I need to make HOH. Well, where does that HOH come from? Let me put it in a different color. Let me put it in blue. HOH. Where does it come from? Well, it doesn't matter which oxygen and hydrogen you pick from, as long as you pick the hydroxyls that are attached to the carbons that participate in the bond. So I've circled the carbons that participate in the bond. So you would have to pick from this hydroxyl or this hydroxyl. Okay, doesn't matter, but you pick 2 hydrogens and 1 oxygen. So what I'm going to do is I'm going to leave this oxygen as part of the structure. So what happens is I can just take 1 hydrogen, 1 hydroxyl, and 1 hydrogen, right? And that's what's going to be produced. That's this. So I'm going to go ahead and erase this because I already have it there. And I'll just put a plus sign and say that's a product. Now, what's going to actually happen is this oxygen is now going to participate in a bond that links the 2 sugars together. Okay. And that is how you draw. Let's check to make sure. What did we say? This was a beta 1,4 bond. So am I in beta configuration? Beta is cis. So I have up and up. Up is cis. And then I have my 4. So I have my carbon on my other ring. It's the 4th carbon that is participating in the bond. So I am good. Okay. Let me know if you have any questions. Good luck.